Hello, statistics student. This video is for 2.5, 2.6 part 3. The last part is to calculate mean from a frequency distribution. In case you do not have your data, but you have data from a frequency distribution table, like one over here. So your data is missing, or you copy your data from someone else, but they only give you a summary of from a table. That means you only can tell that the grade from 50 to 59, there is one number, but you don't know what it is. 70 to 79, there's two of them. You don't know what the two grades are, but you still want to find the mean of the grade. Okay, not the mean of the frequency, but the mean of the grade. So it's kind of as if you are recovering the data and find it. Now, unlike stem plot and dot plot, you cannot recover your data anymore, because the data is, once the data is documented in a frequency table, you only know that it is in this range. You do not know this, say for example, this 5 data, what value it is. So the idea is to use the class midpoint to represent this data. So if I have one data, I would find the class midpoint. Do you still remember what class midpoint is? It's the lower plus the upper divided by 2. So in this case, if 54.5. So I would pretend that there is one 54.5 and there's two 79.5, 74.5. So find all the class midpoint and then just pretend that you have those data and find the mean. And we call those grouped mean. Okay, grouped mean. And the formula, exact formula to do this is you would do the frequency times the x value. The x value is actually the class midpoint of each class divided by the total frequency. So, and you would calculate it as an x bar, assuming that this is from a sample. So, but from statistics, you can actually calculate it by actually generating those data. So there is a, so look at the browser. And I have statistics. Let's clear all this. Clear everything. So those are the ones that I have left over. So I want to enter my table in it, and for statistics to generate the data for me using class midpoint. So what I'll do is I would copy my frequency table, 50. So 50, 60, that's all the lower class limit, 70, 80, 90. So now you enter this. I want to remind you, a lot of people get confused that they enter this in the sample editor. This is not the data, it's a frequency table. So you don't enter them here. You enter it in the frequency table by going to data, go all the way down, frequency table generator. And then the upper class limit is 59, 69, 79, 89, 99. The frequency is you just manually enter them, 1, 0. I didn't try to cut and paste them. I don't know how it works, if it works. So this is exactly the frequency table that you have. And then what you do is you would go to the bottom. Okay, so these are not what you want to do. You would do ask them to generate the data for you. Generate to 1, because column 1 is free. I want them to generate. Look at my frequency table and generate. See how they would generate the data now, not in sequence. They actually would randomly generate 94.5. I have 4 of them here, right? So they distribute everywhere. I think they are trying to, randomly generate the data, but you can see that these are all class midpoint. Now that I pretend to have this data, I am going to do data, descriptive statistics, column 1. That's not my real data, but it is very close. And that is my mean and median and mid-range, 84.5, 84.5, and 74.5. Well, actually, we only want the mean in this case. This mean is 84.5. So I go back to my notes and I say, for this, okay, 2.6, for this select, use the, find the grouped mean. The grouped mean X bar is 84.5. So these are the steps. Use a table generator, generate the data in the empty column. The third example I wanted you to look at is if in case I don't have a frequency table, but I have a histogram. You want to find the mean and median from this. So what you can do is you can do a frequency table from it if you want to, or you can actually write the data out. Now this, when I say 3 here, is actually not the lower limit, but actually the class midpoint. So you would just say 3, 3, 3, 3, 3, 3. 8 of it, right? 8 of them. So maybe I'll just use a table and I say this is the class, but this class had 3, 8 times frequency. 4 is 4 times. 5 is 2 times. 6 is 2 times. And 7 is 1 time. And then I am going to enter it into my table generator. Oh, it's gone. Because I only have one number, what should I do? So you just say 3, 3, 4, 5, 6, 7, 8. You use the same number to force it to know that this is the only number in this class. Because sometimes when you have discrete data, they are actually like that. Okay. And then what are the frequency that I have? 84221. 84221. Oh, did I left something? 84221. I don't have 8. Right, I don't have 8. So it's a mistake. Okay, so and then I will generate my data, but I want to put it in column 2 because column 1 is occupied, and I say generate. Don't worry about any of these. You can see, now it generates. It generates actually in a decimal place also. And if you don't want to, you can say number of decimal to 0 also, but I think it's fine. So then you would do, to find the mean and median, you just do explore data, column 2. Now, those are not your real data, so you can see that mean is 4.05, or actually 4.1, and median is 4. So, you can say mean is 4.1, median is 4. Now, that's the same. According to what we have in the last video, if they're the same, they're supposed to be symmetrical. They're not supposed to be skewed, right? But it's very skewed. So it is very skewed to the right. So this is an example to show you that sometimes in some situation, when the mean and median are exactly the same, it could be very skewed. So you can say you cannot use the fact that they're equal to say that data are symmetrical. But you can do it the other way around. To say if the mean and median are not the same, they must be skewed. Okay, so that is about skewness, and also find frequency, find mean from a table. Okay, so basically you use the this frequency table generator. The generator is to generate the data, but the data is not the actual data. The actual data could be all 90 here, but we just pretend that they're all 94.5 like that. Okay, so that is all for 2.6 and 2.7. No, 2.5 and 2.6.